average Visa level, we were getting a 33% orphan rate. We took that as very, very encouraging.
Mm-hmm.
The assumptions on the quality of the network, I asked Nicole about it. He said he used basically the network that your cell phone has. So he basically didn't have internet backbone type connections. So I think that might be able to reduce that orphan rate if it actually went live on real data centers with real fiber optic internet. I think if you actually went live, the hardware would be at a higher level. So you should expect that 33% to go down.
I live unbanked off of cryptocurrency, and I use Bitrefill extensively because it lets me pay with crypto at places that don't yet accept it directly. This one service, more than any other, helps me live on crypto, pay your prepaid phone bill, or buy gift cards to thousands of major retailers around the world, all with cryptocurrency, including for exact amounts so you don't have to buy more gift credit than you need for a specific purchase. You can use Bitrefill without an account, but if you get an account, you can earn rewards points, which translate to savings, and you can also hold a balance denominated in dollars or euros to protect yourself against market crashes. Go to bitrefill.com, click Create Account, and enter the referral code DCN, or follow the link in the description. So, hey everyone, I have the wonderful pleasure of speaking with my good friend, Dr. Darren Tapp today, the chair of the board of supervisors of the Dash Investment Foundation currently. Did I get all that right?
That's right, yeah.
Yes. So, but that's not what I'm here to talk about today. Dr. Tapp is a fantastic researcher and mathematician and has been involved in scaling research for Arizona State University, specifically about the Dash blockchain, but I'm sure quite knowledgeable on just the general concept of scaling and on-chain scaling and stuff like that. So that's kind of the whole purpose of kind of getting into this conversation is, as always, the biggest debate in the history of cryptocurrency, I think it's pretty fair to say, is scaling. Can specifically Bitcoin scale on-chain, or can it not? Or what are the drawbacks of scaling on-chain versus off-chain? And Bitcoin BTC seems to have pursued this off-chain scaling thing in favor of things like everyone should run their own node on a Raspberry Pi and things like that. And then things like Bitcoin Cash, Dash, things like that have gone the on-chain scaling route just to the max. Bitcoin SV has gone the everything on-chain. You know, just anything imaginable that you want. Like put your little cat on-chain or whatever. Everything, it just goes, put it all through. And every Twitter message, everything is on-chain. And then there's, of course, a bunch of other solutions and a bunch of other things that do that. So this is a great conundrum. It's been such a political thing, unfortunately, when it really should be like a scientific thing, basically. And so, first off, basically, do you think that on-chain scaling is viable for a money kind of a thing to reach global adoption levels?
For a currency, I'm quite certain that I'm quite certain that average Visa level is possible. If you had a cryptocurrency that was focused on just transactions, I think that average Visa level is in reach with current technology without really raising the cost of the network. Perhaps you would pay a bit more for a hard drive, but almost at the current hardware level that's being used today.
And so, obviously, the way you'd get that with traditional cryptocurrencies would be raising the block size so that you could fit more transactions in each block that comes by every 10 minutes or 2.5 minutes or whatever it is.
Right.
And then is it, obviously this is the stupid newbie question, which I know is not correct, but is it just that simple? You just make the blocks bigger and everything works just fine? Or do some things happen possibly negatively when you do that and you have to either optimize or innovate, or you have to have some trade-offs?
Well, we did research that question, and we mainly focused on the block propagation technique that's used. That was basically our variable. Basically, we had two stages of our question: how much can the network handle at its standard way it's working now? And if we use some propagation speed ups, would the maximum change? Would we be able to handle more transactions? So that's what the question more or less was. And so our first paper that we came out with, we investigated 3 propagation protocols, which one we just called one traditional. That was the one on the original Satoshi client that transmitted the whole block as soon as it was found. And then we studied compact, and so that's currently used on the Dash. In the Dash, the Dash client uses the compact blocks, as does the BTC client. And we also studied XThin, which came out quite a while ago. Bitcoin Unlimited, I imagine they're the first people that implemented it. And you know, when it first came out, there was a DOS attack vector that was open, and so some of the unlimited nodes went down. I think the discussion in the community may have been a little disingenuous after that point, because they were saying, "Oh, the nodes are going down. We can't use XThin," but at the same time, that attack vector's been closed, and it's currently Bitcoin Cash nodes. Some of them, at least, are using XThin without any problem. So we studied these 3 propagation techniques. That was the first thing we did, and keep in mind that this research is, I think it's like 3 years old by now. 3 years old by now. It's been a while, and one thing about the research being old is that we assumed, you know, quad core computers. We assumed the bandwidth that was normal at a data center at that time, you know, without like any severe cost, like a $20. We assumed that you were paying $20 a month for a server, and so the fact that we did that research so long ago, you know, bandwidth improved. So actually, you know, we may have a lower bound on the scaling limit. I would expect it's more now with, you know, better. The internet just keeps improving. Anyway, so we found with traditional block sizes, actually Dash couldn't really support 1 megabyte blocks. We now there's 2 limits. Like the network would be fine. You know, like the you know, there wouldn't be, but there's basically the orphan rate might get so high that miners may opt into having smaller blocks. And back then, when we did the calculation, we came up with about 750 kilobytes, which would have still been 3 times what Bitcoin did at the time.
Because Dash's blocks go out faster.
Yeah, so that was, and the miners could still use more space. It's just that we were concerned the orphan rate might not make it in their interest to do so. And then we also did the analysis with compact blocks. Compact blocks had a kind of a different failure mode. It kind of works just fine. And when it failed hard. And so with our estimation of that, we believe the Dash network can handle 4 megabyte blocks with no problem. And so compact is live right now. So if they wanted a hard fork from 2 to 4, I don't think it would be. Actually, we know it's not going to be a problem with the simulation. We know 4 megabytes is perfectly fine, but we do think that compact blocks does have a failure mode that is kind of a worse failure. Basically, when you start failing, you know, does everything fail, or does it just have a little bit of hardship, like the miners are choosing not to do as much. So the failure mode was worse. Anyway.
Yeah. So when we're talking about scaling, and we're talking, you know, sort of bring it down, a hard drive space necessarily isn't the deal. It's mostly, as you're talking about, propagation. Basically, a node can get a block out full of transactions, and it reaches all the nodes in the network. And at a certain point, if there's too many nodes, it's harder to propagate to all of them in time. And so that's like one of the bigger ones. And then that's the challenge, is how do you get the block out before it even gets included by miners? How do you just get it out to all the nodes on time. That's the problem. And then what failure looks like is orphan rates, where the block will be dropped. It just won't be picked up by miners. And so if you have a high enough orphan rate, you just have like a bunch of transactions failing, and then that's just no good at all. So that's kind of like the seesaw we're trying to figure out, right?
Yeah. A block gets propagated to the whole network. It gets included in the chain, but there's a chance that there could be maybe two blocks found at the same time, or if it takes a while for the block to propagate to the whole network, that a new block could be found by somebody else.
Yeah.
And basically, when that happens, you have a network that's kind of temporarily out of consensus. And eventually, one of the two blocks, at the time there weren't chain locks or anything when we were doing the research. So one of the two blocks eventually will have a block on top of it, and then the whole network's going to coalesce around that chain. But then the other block that's not included in the chain is called an orphan block. So that's what we're doing. So what we try to estimate the orphan rate as we scale up, and if the orphan rate was getting too high, which really we want it to be under 1 or 2% for a normal working blockchain. So really, the orphan rate for Compact was like basically 0 up to 4 megabytes, and and then also if the orphan rate increases, that basically the fees, just from economic considerations, the fees should start to go up slightly. Not like they went up on BTC, but they should just go up slightly because the miners should want to have a higher premium to justify a higher chance of orphan rate. So with compact blocks, there's basically hardly any orphans until you get to around 4 megabytes. So that's so the miners shouldn't really need large fees to justify these blocks. Now, you mentioned hard drive space. That's one thing. We didn't really consider that in the cost of the node. With a Bitcoin node now, or at least when we were doing the research, you could have a 2 terabyte drive, and it would hold the whole blockchain. I hope there's a day that Dash gets to that as well.
Yeah, because I have just a basic laptop, and I have a Dash node on there, and I run it, and I have the whole blockchain, and I do videos as we're doing right now for work. So I do have to empty out my videos once in a while and put them on external storage. But just the fact that I can have like tons of videos on my laptop and the whole Dash blockchain, it's not that much of a problem now. And of course, if you have like a serious node of any kind, and you have, storage space is getting extremely cheap. So it seems like the block propagation to all the nodes seems to be the big kind of barrier. I wouldn't say it's like it seems like that's mainly the problem to attack. Now, how high do you think, obviously as technology improves, it can probably go higher, but how high do you think we can get as far as daily transactions on, let's just say first off, how much of a difference is there in deciding a block interval? Because Bitcoin decided 10 minutes, and that works clearly to a certain extent. But almost every more modern, at least proof of work cryptocurrency I've heard of, uses around 2 to 2.5 minutes. Like Monero, I think, is around 2. Dash is like 2.5. Litecoin's 2.5. Zcash is 2.5. Almost all of them are about a quarter of that. So obviously that just means how fast the blocks come out. And and I know there are some that have like a few second block interval or whatever like that. So what is the difference between these block intervals from a scaling perspective, of course?
We didn't directly answer that question, but with the data we did receive, we kind of have a feeling, let's say, like I wouldn't put it in a published paper, but I have a feeling that the blockchain network's going to scale easier having more blocks that are smaller. So like the Dash network having the blocks come 4 times as fast, you can have the same amount of transaction throughput with a block that's a quarter of the size. And I believe this feeling is backed up by the thinking that when a new block comes in, especially if there's transactions that haven't been seen before, the all those transactions need to be processed at once, right? And and if you can break it up in smaller chunks, that seems to kind of make sense. Basically, you're every time a block is propagating, that's when the demand for resources from your server are going to be the greatest. And by chunking it up into a quarter as much, perhaps more often, but you're demanding less more often.
Yeah.
So the
what
problem
about like
is
a
you don't
second?
want to demand. Oh,
Like
hold
if you do a block every second, let's go ridiculous on this. What's the problem with that?
on. Well, then, so with our orphan study, it's very, very rare that you would ever have two blocks that get orphaned off. I mean, you almost would need a network problem for that to happen. But if you went down to a second, then you know the chances of having a divergent chain get to be much more. And like you said, it's trade-offs. So it's kind of like 10 minutes you get some security. I think dropping down to 2.5 or even 2 doesn't really
Increase
do a trade-off.
Yeah.
But if you were doing a second, then you might need 100 confirmation, 100 seconds before you would trust it, trust the transaction. Or we're now with Dash, before chain locks. I felt very confident about a transaction once it had one confirmation, and with chain locks and with instant send, I feel very confident before a confirmation, and also extremely confident after a confirmation. So
yeah, we'll get into those the special
and
bits.
after confirmation and a chain lock, I feel extremely confident.
We'll get into the special bits in a little bit, but it seems like that's sort of the sliding scale. Is the entire thing we're trying to look for is speed of transaction, but more importantly, it's speed of confidence in the transaction. Is how fast can you get to believing in the transaction? And so from a purely blockchain confirmation kind of thing, 10 minutes is great, but you can probably get that in 2 or 2.5 minutes. But if you start bringing it low, then all of a sudden, even though you get a confirmation faster, you don't get confidence faster. It starts to be a law of diminishing returns as you go below too.
Yeah, and if Dash had a second block interval, and didn't try to do chain locks, I wouldn't be too happy with that, because it can take about 2 seconds to have the chain lock get to your node. So if that 2 seconds is time for another 2 blocks to come out, that makes me a little bit nervous. So I think even under heavy use, the chain lock's going to come out within 15 seconds or something. So but it's not going to take before the next block comes out on average. So
so upper limits of scaling, right? Or you're talking about like Visa levels and stuff. So with what we know we're taking 2 scenarios: what we know today and what you could reasonably expect in a couple of years. And obviously just estimations, right? But how many transactions could you be able to process on a regular blockchain? Let's just pretend Litecoin for because we leave aside Dash's special features for a second. Let's just pretend Litecoin, which has the same block interval, decided to just start increasing their block size and using all the latest propagation techniques like XThin or whatever, and just try to get as many transactions on chain to be pretty reliable, like almost like reliable enough that you trust your money with this stuff. How many transactions per day do you think a network like that could process in 2021, let's say?
You mentioned Litecoin. Litecoin has SegWit, and I'm not quite sure how SegWit would affect these numbers, but let's assume that they never did SegWit.
Yes, because it's opt-in
I don't think that would. I don't think SegWit would increase the speed of the network at all, or increase the throughput. But anyway, so Litecoin right now, I think they use compact blocks pointed over from Bitcoin, so they should be able to handle their whole 1 megabyte block, no problem. Dash has 2; they should be able to handle that. They should be able to handle 4, no problem. If they wanted to go up if they did if they were interested in scaling, they could implement something like XThin. and then we would expect maybe a limit. We're not sure where, but like we assume, we don't assume, but we have evidence that 10 megabyte would work without a problem if they use XNet, which that I think you had me do the math. It was half PayPal speeds,
Yeah.
half PayPal throughput at 10 megabytes. Now, let's see. Yeah, so that's doing pretty well. That's with XN. That's not the upper bound. That's just where that's as far as we could take our simulation. So
Yeah. So from what you know about it, what would happen if they went to like 100 megabytes with that block interval or something? The same thing. And obviously, like, do you think that it's reasonable to expect that you could scale to, I guess 5 times PayPal's limit right now? With yeah,
100 megabytes. I think the network would stay together. There's no chain locks to worry about, no instant send to worry about. I think the network, but the orphan rate would probably be not too high. Would be higher than you would want it to be. So it could be around 5 or 10%.
Yeah, and that's using, say, XThin and all the stuff we know about right now.
Yeah, that's just using XThin, right?
Yeah.
And then so we worked with a grad student, Nakul, who invented what we call he applied basically BitTorrent technology to block propagation, and with that we have that we think it can go much higher from there. If we use we call that the velocity protocol.
Yeah.
But the only data we have for that is the simulation. And with science, you would want to do simulation, emulate. You want a second person to verify your results. We don't have that yet. And we would also want to do like an emulation or even a test net, before it went live.
Yeah. So obviously,
I would say that's still preliminary, but that was published and accepted. So
obviously, it's not science with the velocity protocol yet. It's not like proven.
Well, it is. It is science, but science basically requires a second
of course,
confirmation, and we don't have that second confirmation.
So from the first confirmation, then, how big could a network like that scale to?
Well, we were getting a orphan rate of 33% at average visa level. So that now there's two things: average visa level and peak visa level. Of course, you'd want to go up to peak visa level, but at average visa level, we were getting a 33% orphan rate. We took that as very, very helpful or very, very encouraging. The assumptions on the quality of the network, I asked Nakul about it. He said he used basically the network that your cell phone has.
Yeah.
And so he basically didn't have internet backbone type connections. So I think that might be able to reduce that orphan rate if it actually went live on real data centers with real, fiber optic internet.
Yeah, because we're talking hobbyist stuff still, kind of.
Yeah, I mean, when you do these simulations, you assume that the hardware is at a certain level. So I think if you actually went live, the hardware would be at a higher level. So you should expect that 33% to go down. Now, just to get the simulation to run, I think he only used 14 nodes or a handful of nodes. Our first study, where we studied traditional compact and XThin propagation, we assumed 5,000 nodes, which is basically what we assume the masternode network is. At least 5,000. 5,000 nodes. That's pretty much where
how many nodes Bitcoin has consistently over the course of a day? I've seen like over 10,000 figures, but I don't know if that's like always like just consistently running, or if they just have popped up on the network in the course of a day.
I've spot checked. I think there are around 30,000 nodes for Bitcoin. I mean, it is, being the first project, it's Yeah, so I mean, a Litecoin will have a handful. It was funny, we're talking about Litecoin scaling. Litecoin did have a problem, a couple years ago, and I couldn't really I couldn't really figure that out. But my hypothesis on why it was having a problem was because it had a few number of nodes, and and so if it like basically if there's only 200, 300 nodes that are full nodes, and when I say full nodes, I mean with a symmetric internet connection that's on a VPS or something like that. So if it only has 200 or 300 reachable nodes, I guess that's what it's called. Then all the people connecting it could kind of like clog up all those nodes.
Mm-hmm.
If we have 5,000, then like 50,000 people could connect and kind of not really clog up those nodes. There's plenty of spots open.
Yeah, of course.
And with the way that Dash is doing the changes, the master nodes now are going to have like 300 connections. It used to go it went from 40 to like hundreds of connections. And so this master node network is going to be hugely interconnected. I think the reason why it wanted hundreds of connections is to make the chain lock much more robust. So it was working before, but now with these 016 changes, it's going to work even better.
As far as, so it seems like you're very hopeful that it's pretty established. You can go to major payment network level, like, half of PayPal in short order. And then from preliminary other research, such as with the Velocity protocol and stuff like that, you're saying average day Visa level transactions are highly possible, and I guess realistically in the next couple of years that could be made ironclad. Maybe. Again, I hate to use these kinds of vague statements when I know you're a man of science and likes everything super proven, but basically it seems like on-chain transactions should be able to scale pretty well. Now, I've seen a lot of noise out of especially the Bitcoin SV community about scaling, about there's like no upper limit. You could basically pretty much infinite scaling kind of a thing, and talking about, we're doing gigablocks and we're doing more gigablocks and all this kind of stuff. And it seems like you're on the same like general wavelength of you should be able to scale a proof of work network on chain to large enough to support a lot of things, but you're in a very much more cautious kind of like, well, this is what we see, and there's some problems here. We'll get those figured out. We'll see as we go along. But they just seem to be like, woohoo, like, can scale as much as you want. So what are the problems with, or are there problems with that kind of a thing?
I have some contacts that are kind of in the BSV space, and I haven't had time to research it specifically, but things I hear are they're putting, like, pictures, like full pictures and full the information on the blockchain, like maybe even a movie, for example. Like I don't know, but so pictures can be kilobytes or megabytes of size just for one thing, and and they say that it'll scale, and so great, that's their claim.
Yeah,
and they have it on a live network now. So now this is great from a science perspective, because we can just take that data, and if it fails on their chain, then we know not to do it. So basically, they're saying that it should work. So just let them do it and see if it works.
Yeah.
And because maybe they come out with they can go better. Yes, I feel like we were conservative in our things, and so if they can go more than what we found, then I don't feel like that we I feel like that's even better, right? But I wouldn't recommend to the Dash team to start putting movies on chain right now. I think it's better to have that space available for the main event, which is transactions. My understanding when I was studying Dash platform a while ago, like the pictures that are used for like the Venmo type experience, those aren't. There might be a hash on chain, and then there's also two chains to help kind of distribute the load. So that helps one with scaling one way. So there's a platform chain and the transaction chain. So that helps scaling the load for things like pictures that could be kilobytes or even kilobytes. They'll actually would anchor that picture on the chain with a hash. So you have your immutable, here's the picture you want, but the masternodes might store that picture, but it won't be like every masternode stores that picture. So it might be 1 out of 10 stores that picture. So that way, that way for Dash scaling, that picture could be available. You just have to query 10 nodes. And then when you get the picture, you can verify that hash and know you've got the right picture. But the fact that there's only hash on chain has kind of freed up a lot of space for scaling. The fact that you turn down the redundancy a bit, frees up space for scaling. you know. So it was done with a lot of scaling stuff in mind. The paper we didn't consider platform and all that.
Well, that's a great time to jump into some of the things that will make Dash a unique puzzle to scale. Because we're talking about scaling just a regular on-chain cryptocurrency network where if you broadcast a transaction, it goes out there. It's probably going to eventually confirm, but you're not sure of that. And then eventually if it gets a confirmation in, let's say, Dash or Litecoin's case, or Bitcoin Cash, or Zcash or whatever, 2.5 minutes, it gets confirmed. And then once it's confirmed, once it's in a block, it's relatively ironclad, even though, obviously other stuff. But Dash has 2 extra things. One, working backwards, I guess, chain locks, which use the master network to, after a block is confirmed, to actually lock in the block and make sure that it doesn't get rolled back ever, just to make that block permanent. And then we're going back to just when you send out a transaction in about under 2 seconds, it gets locked until it gets included into a block with instant send. So there's 2 different things playing on top of the just regular old proof of work network to basically make them almost irreversible instantly and absolutely irreversible in a couple of minutes, basically. And obviously, absolute, or that's not a scientific term there. I'm just saying it's a little hyperbolic. But basically, just super ironclad on top of that. So what are the scaling considerations that's brought up? Has it obviously, and obviously for context, not too long ago, someone decided to, after every transaction became instant send locked, someone started kicking out a ton of transactions, a stress test, spam attack, whatever you want to call it. And there were some issues with instant send locks failing from my memory. I don't remember too well. But so clearly there's some things that have extra considerations when you go to scaling with this special kind of network. So what are those?
Well, that's one thing you do want to consider. How that works. I do believe they have some improvements on instances. So they did this stress test, and they did. So I believe they have more or less fixed that. The main thing you basically you had the old way before instant send and chain locks, and if you have all those old wallets that don't check for the instant send or don't check for the chain lock, you do get kind of like a herd immunity or extra security just using Dash. But I feel like in order to say that you've got the ironclad stamp, you should definitely check for that. If the instant send fails, then you just need to wait. It goes back to the Bitcoin security, which that's worked very well. But they're generally under normal use. It shouldn't fail. That's pretty much that's it. And then there's the stress test happen, if you want to call it that. And then there have been improvements to instant send since then. So it's a completely new thing. I mean, there's a problem with the and we hardly ever mention it, but instant send transactions. So if you get proposal for more than 15 inputs, won't get an instant send lock. It just won't.
Which is pretty rare, I guess, right? Unless you're using like a mixing thing. And so, So for example, like I'm, guilty as charged. I regularly use private send or advanced coin join mixing stuff, and it according to optimal privacy recommendations, you should keep them under 10 inputs. So instead, usually it'd be like a regular transaction would be like 1 or 2 inputs, so like something very small. But when you under different circumstances, like mixing explicitly, you could have a whole bunch. And so if you have like I have sent a couple that have been larger than that, but I guess those just don't get instant send locked, and then they probably, again, they probably show up anyway. But anyway, basically, instant send locks all those that are under a certain amount of inputs, and obviously the master network, or a network of nodes, in this case specialized, high-powered, incentivized nodes, have to just lock that. And obviously that system has its own scaling limitations of some kind, or considerations that are separate to just block propagation, right? So how high do you think let's just say the current 5,000 node dash master node network, it's not that 5,000, but whatever, how high do you think that can scale as far as locking just about, let's just say 90%, for argument's sake, 90% of instant send transactions?
I think it can scale as needed.
Yeah.
So I guess you're giving me the SV thing. Let's see. The problem with the original Bitcoin scaling, every computer had to check every transaction and all that. So with an instant send transaction, only 40 masternodes need to check it, and actually 19 of them can be, well, anyway, at least like 10 could be offline and it'll still work, because they only like 24 out of the 40 need to say yes. Instant send lock, right? So so instant send right there is for every transaction, it doesn't have to be instant locked by every masternode. It just has to be locked by 25 of them.
So that means theoretically it's several times more scalable.
Load.
It's like several times more scalable, because you only need a fraction of the network at a time working on that.
Right. So like if you had let's see, 5,000 over 40, so that's what, 100. So if you had 100 transactions set to the network, the node only sees one. So.
Yeah. So basically, this scaling instant send isn't. If there are problems scaling instant send, it's more of a bug kind of a problem. You got a bug to fix, rather than you're actually hitting up limits and you have to do optimizations to get more throughput.
And under normal use, the transactions should come through more or less kind of in a uniform distribution in time. So, when the problem with new blocks is you might have to verify a bunch of transactions at that time. So under normal use with instant send, that shouldn't happen.
Yeah. Now, what about chain locks? Because chain locks locks the first seen block that shows up. And so what are the considerations about that?
So with chain locks, computer resource-wise, it shouldn't be an issue, because only every 12 hours there's basically 400 masternodes that are picked to do the chain lock. So only those 400 need to keep track of the chain lock. A regular node just needs to keep track of the key for this quorum, and then the regular node can just verify all the chain locks as they come. If Dash was scaling and the transactions really started to come, and then the block size gets like around 5 or 10 megabytes, and so the orphan rate goes up somewhat. It wouldn't be that high. A higher orphan rate in a chain lock environment could result in perhaps chain locks failing for a particular block. When you have that orphan, if one of the two blocks doesn't have enough of an advantage where that 400 masternodes can determine what was their first seen block, then the chain lock will fail. But then that's, I feel bad saying that word, because people are going to assume that's the problem. Then when the next block comes out, then that most likely that'll get chain locked. And the way chain locks works is once you have a block at the top locked, it locks everything below it. So, So I think that you're going to, like right now, we have hardly any instance of a chain lock failing, maybe once a day. It was once a day, but there's been improvements from there. So if we were scaling, we might see a chain lock fail twice a day or something. But if it fails, as long as it hits the next one, that you still get your lock. And if chain locks failed for any particular block, then once you have your confirmation, you have as much security as Bitcoin, right? Mm-hmm. You're back to this Bitcoin security model. So it's not like, but the Bitcoin security models worked very well. So the fact that failure means you're as secure as Bitcoin.
Mm-hmm.
Right?
From a, like, let's just say the network gets all of a sudden, Elon Musk tweets about, I'm using Dash every day, you all should use it too. And then let's just pick some other random celebrity. Donald Trump wants to pay everyone and for his new media company with like Dash, whatever. So a couple people go ape shit and just start using Dash all over the place. The things spike, the transactions spike to like a few million a day and stuff like that. And basically, some chain locks start failing, but rather than just like a Bitcoin style network that is already relative, like when you broadcast a transaction, it's probably not going to get double spent, especially not on if you don't have replace by fee. And then once you actually get confirmed in a block, that's probably it. Maybe 2 confirmations is good. But then you already have instant send, which is locking all the transactions, preventing them from being double spent until they get into a block. And once they get into a block, it's probably permanent because of chain locks. But if chain locks fails a couple times even, then it still succeeds and then retroactively locks everything. So we're still talking about an extremely secure, reliable network, even under some crazy adverse circumstances. Is that kind of correct?
Yeah. That's probably the one I'm not doing a good job of communicating. It's basically redundant.
Yes. There's a lot of redundancy.
Instant send So like if the chain locks fails, once you have a confirmation, you still have Bitcoin security. It's like you've got Bitcoin security, and then on top of that, you've got chain locks, which is kind of more or less a redundant security. The way I view it, as the network collapses into consensus. So with Bitcoin, as you get more and more blocks on top of a block, then that block gets more and more certain that's going to be in the chain. But with chain locks, it's like almost instant. Or 2 seconds collapse. The network collapses into consensus. My metaphors are always more complicated than actual.
But it does make sense.
I think it was just like a quantum state, and it collapses. Like, okay, now we have an observation. And, it's spin up or spin down. We know what it is.
Now, I've heard, of course, a lot of people talk about like zero confirmation is secure or whatever. And obviously, I don't think it's ultimately secure because there are double spends, even on Bitcoin Cash, for example, that doesn't have replace by fee. But my brain, which is, not very advanced, but I try, considers, I guess, Bitcoin style security is sort of 2-step, where you broadcast a transaction and it's probably going to go through. It's not super easy to double spend, especially, or fail or whatever. It's probably going to go through. And so that's like the number one level of security, is just like propagating it out into the mempool, right? And then the second layer is actually once you hit the blockchain itself, it gets into a block, and then it's like a lot more secure. And then each following block, it gets more and more secure. So from my dumb level of thinking, I would consider something like Dash to be like a 4-layer security thing. First off, you put it out, it's in mempool, so it's probably going to go through under old school rules. But just in case, it's locked by instant send lock, which is a second thing, which, can fail, but usually does not, almost never does. And that just makes it extra secure as it goes through to actually get into a block. And once it has a block confirmation, it's probably permanent. But just in case it isn't, there's a chain lock that actually does make it permanent. So is that way off in some way, or is that maybe a realistic way of thinking of things?
Oh, that's right. I mean, like when you get one confirmation with Bitcoin, most people accept that as paid. So with one confirmation at Dash, I would consider it more or less paid. But then with the chain locks, then there's it works even better.
Yeah, so like if I wanted to defraud someone using Dash, it would be extremely hard. Obviously with Bitcoin, it would be relatively easy if they don't wait for confirmations, because with BTC, not
BTC,
not the
yeah,
other
yeah.
ones, because I send
Yeah.
out a transaction with too low of a fee to confirm soon, and then they're like, it'll go through, and then I go double spin it back to myself with a
Right.
higher fee, and then
And
yeah, that's
yeah,
relatively
and
easy. Now, something like
yeah,
Bitcoin Cash is a lot harder to do that kind of a thing. You can
right.
still
Because
double spend, but it's not
yeah,
very reliable.
the original Satoshi client had it was subscribed to what's called the first seen rule.
Yeah.
If your node first saw this transaction, it assumed that was the first one, and somebody tried to just double spin, they assumed that they would see that after,
Mm-hmm.
and that the original Satoshi clients would just drop that transaction, wouldn't more or less help the double spend.
Yeah.
Okay, so that did provide some security. Now, when the whole SegWit discussion was going on, I feel like it was, again, not very genuine discussion, because they were said, well, the first seen rule is not 100% secure.
Mm-hmm.
And we need to do the replace by fee for all this. So then they did the replace by fee.
Which made
So
it much less secure.
yeah, so it's like, and that I actually stopped running Bitcoin nodes after that, because I didn't want to participate in fraud.
Mm-hmm.
And yes, it is possible to double spend with the first seen rule, but at least my node's trying to
Yeah.
do its best to stop it. With
Mm-hmm.
the replace by fee, I didn't have any. I wasn't even trying to stop a double spend. So I don't want to be I don't want to be a party to fraud. So I was like, I won't run any Bitcoin nodes anymore.
Yeah.
And at least make a good faith effort to stop it, right? It's like, that's what I think so disingenuous. Like, first seen rule is not 100% secure, so therefore do something less secure. That makes no sense, right?
Yeah.
But Dash Team knew the first seen rule is not 100% secure, but they kept it because it's definitely better than double spending, or having double spends rampant on your network. So they've kept the first seen rule, and then they've gone beyond it with instant send. So
Yeah. So basically, if I was, and this is like a stupid hypothetical, right? But it always helps, at least me get my brain around this stuff. If I was trying to double spend to, say, like steal a car, like pay for a car, drive it off the lot, and oops, it fails. With Bitcoin, I could do that without anything really too special. Like I could just send it with a low fee on BTC, and then I could, it's going to go through, and then send the money back to an address I control with a higher fee, a high enough fee that I'd be sure that one would end up getting confirmed. Take the car, run. The transaction never goes through. They call, hey, what, but then you got the car, whatever. Now, with something like, say, Bitcoin Cash or something like that, I would have to basically simultaneously broadcast the payment for the car to them and back to myself, and kind of mess up some rules to basically try to make sure that that's the first scene. They would probably catch it, right? First off, it probably wouldn't work. Like, it wouldn't necessarily work. But even if I did try, if I was an expert Bitcoin Cash double spender, which is kind of a weird thing, they might pick up that, hey, it got dropped before I'm even off the lot with the car, right? So it's possible, but it's like, I wouldn't do that, especially not face to face. It's not easy. And now you go to, like, with Dash. With Dash, I would have to do that, roll those dice, etc., and I would have to somehow disrupt the network so that the instant send lock actually failed when I sent it. Don't worry, it's instant, it's going to work. And then, so we're already getting to this big old minefield. Like, how hard is it? You basically have to, like, disrupt the whole network in order to even get away with that edge case of fraud.
You would have to disrupt 40 nodes, and they would have to be very specific, and they would be changing over time. So,
so it'd be very, very, very tricky. And then,
and then each one of them costs 100,000 right now. So it's like, So how are you going to do that?
And then it hits 2.5 minutes until it becomes permanent anyway. And so, if, like, the worst that can happen, you have to wait 2.5 minutes. And then there's like, hey, this transaction didn't go through. In fact, it went straight back to you, and we can prove it. Like, you stole the car. So It's like you have to like have some people disrupting just the right data centers at the right time as you're trying to do this, and you have to get off, like, shake the guy's hand, drive the car the hell away in just a couple. It's like, it's really ridiculous as far as like how you could even attempt fraud in this thing.
Yeah, it's I don't know.
Yeah, which
There
is
you go.
which, as far as money is concerned, that's what people don't want to. If someone hacks into their Twitter, that's one thing, but if people hack into your money, that's something else, which is why you need something this secure. But you mentioned stuff about Dash platform and the differences as far as like what you actually need for requirements on that, like hashes and storing things here and there and stuff like
Right.
that. So from my perspective, for those who don't know too much about Dash platform is coming out, which is the basically the data network, the data contract network that'll basically power the usernames and contact lists and decentralized apps and stuff like that. As part of that, there's a second chain, a side chain, as it were, the platform chain, which is not necessarily it's not necessarily the same at all.
It's a completely different architecture than
Yes.
the payment chain.
And it's with much lower, I guess, security kind of necessities, right? As far as like as far as from my understanding, so blockchains are usually never, like, as in the major ones, are never like pruned. All the nodes have all the history pretty much. I mean, with a couple of exceptions. So from my understanding, first off, with platform chain, you'll be able to just delete, I guess, from your node running it, delete some of the past little interactions on this special side chain, and there might be a few archive nodes that just have the whole thing that are even beefier.
That's right.
And so you basically don't need all these extra layers of security, because it's basically small actions, like I updated my profile picture, I friended this guy, this and that, and these little things going back and forth.
If you change your profile picture, it might not hold on to your old one, but it will keep your new one. So
yeah, exactly.
That helps with scaling. You can't hold on to Joel. When let's say Dash was around when you were 12 years old, we can't be holding on to a picture of you as a 12-year-old for forever.
Yeah,
so.
And I'm sure some people.
But there might be an archive.
Yeah, I'm sure some people would want to possibly pay for something extra like that, but that's 99% of people are okay with just their most recent profile picture or their most recent Twitter bio or whatever it is, or their just most recent like display name being kept. And so because of that, I would say platform chain is much more scalable than like the main Dash network or something else, because you don't have to keep as many things.
So I think so. It's going to allow kind of some of the smart contract functionality without the severe scaling restrictions that Ethereum's currently having. Or at least it's got a tenfold start where it can and the type of data it can store bigger files, and so I think it's going to be more useful right off the bat, and retain being more useful as it scales, or at least it's not going to have a limit. Its limit will be a much higher than Ethereum, say. Now, when I say smart contract, that's a little bit of a stretch, because smart contract, I would say that's like a Turing complete program that's on the chain, or a program that's in a Turing complete language on the chain. Dash platform, from my perspective, is more trying to mimic the usability of a database, so that when computers first started and they started using databases, there was a huge amount of applications you have right off the bat, just being able to have a database. So the idea is that maybe we restrict the functionality to be more of the functionality of a database, and then that allows for scaling in ways that having Turing complete programming language and every node verify everything. We're seeing that Ethereum run into those limits right now. So So I think that's an advantage there. I did notice there's I think it's a DIP 20 that will bring in the old opcodes in that, like basically what Bitcoin Cash has done. It fixes the old opcodes and brings them in. That would, cause more demand for space if people were using those features, space on the main chain. But I think that the way they're, doing the architecture of this is fairly smart. There's also, you can look at DIP 5. So DIP 5 is kind of the bridge between the main chain and the platform chain. So the platform chain has all this other information, but in DIP 5 it'll have where on the main chain you put transactions on the main chain, which is it might be the most secure because it needs to be, because that's where your transactions are. But you put a transaction on the main chain that registers your identity.
Yeah.
And so there's going to be kind of an interplay between the main chain and the platform chain. But you register your identity with a public key on the main chain, and then you can use that public key to update information about your identity on the platform chain. So, and that's basically the first app. It's the app that keeps information about your identity.
Yeah.
So I think that was called the Dash Pay app.
Still is.
Yeah. So that's like the first go. But then, I've been talking with Andy Freer, and they're doing a lot of exciting things about, having apps with more, that offer more services, basically. Yeah. And then once we have that Dash Pay identity structure, you can kind of bring the identity into the app. So think of apps kind of as websites, I guess. So many websites you'll actually log on to, and it puts a cookie on your computer, and it's easy to hack websites often. Sometimes the password thing isn't always the best, most secure thing to do. But with an app on Dash Pay, it's kind of like you're already logged in to your identity, and then if you want to start interacting with an app, you can just say, "This is my identity," and you don't have to log in and you get, and for my assessment, you get more security than if you were remembering a username and a password. Yeah. Because it's all with the cryptographic keys, and then you have your own key on your wallet, and you don't even know it, and that handles all the security for you, and you don't have to worry about your password. So I think this has been the most underhyped thing that in the crypto space. Yeah. But part of the reason I think it's underhyped is everybody's just trying to get it done. Yeah. And and
that's for sure.
And it's yeah. I don't know. What can you do? You're like, oh, here's a good idea. Okay, let's do it. Okay, it took 5 years. Okay, we're almost ready. Okay, you can test it now. It's like we think it's going to be huge.
Yeah,
we'll see.
I have gotten a lot of people excited about it just by describing decentralized digital identities and what you could do with that, and that's going to be huge. But let's kind of bring this whole thing full circle to wrap it up. And when we're talking about scaling and scaling things on chain and the limitations of that, I think we slogged through pretty well as far as how we can scale, how big we can scale, what are some limitations, things like that. But now, to the last bit, what are the trade-offs? Now, we're mentioning, when we're talking about Dash in particular, Dash has master nodes, which are specialized large nodes that basically they can do a lot of stuff that a regular node might not be expected to do. As in, because they're actually paid to do this stuff, to keep uptime and things like that, then they can actually afford to spend money on high bandwidth connections, on hard drives, and good stuff like that to make sure. So it's basically not the average hobbyist node necessarily, and that can be automatically scaled up as there's more requirements on the network. Now, one of the big things I keep hearing the Bitcoin people saying is it's important to be able to verify your own transactions yourself. So therefore, you should run your own node, and we want the on-chain network, even if it sucks and you can't pay for stuff because it's expensive and slow, we prefer that everyone be able to just run a node on small stuff like a Raspberry Pi with like some extra hard drive space or whatever. And that's kind of what they've optimized for. So I guess, is it an accurate assessment that if you're trying to scale to like Visa levels on chain, that we've already kind of talked through that is theoretically possible with, possible to do so efficiently, that the nodes involved at that point would be basically have to be beefed up, like, you'd have to run a data center or at least invest in some specific infrastructure to run a node. Is that kind of where we're at?
Yeah, with Dash, running nodes in data centers, that's going to do. Yeah, I actually think you're bringing up another disingenuous part of the conversation. Yeah. That if you got to run your own node or you're not secure. That I don't think that's was 100% correct. If you wanted to just do a transaction to know you got paid, you can run these SPV wallets, and that was right out of Satoshi's paper. It wasn't like a new technology that people were still understanding. But if you have the transaction, your local node, an SPV wallet will download all the block headers, and block headers are quite small and they're the same size, so no matter how many transactions, they're the same. And then once you wanted to verify that you received a transaction, you can actually do a Merkle proof and prove that any particular transaction is in that block. So that actually gives you a lot of security. Since the advent of instant send and chain locks, I was trying to make sure that SPV wallets could actually verify the instant send and the chain lock. I think that's taking a little bit. Basically there's a whole bunch of node implementations, so you've got to worry about each one. But I think it's certainly possible to have an SPV wallet that can take advantage of chain locks or instant send, and get that level of security. If you were using an SPV wallet and you didn't actually check the instant send yourself, you still get what I call the herd immunity, the fact that everybody else is doing it. So you still get that level of security. And then let's see. Oh, and then to try to help with Dash platform to help your phone that doesn't have the resources to run a full node, in my view, to help your phone or your Raspberry Pi, interact with the network, there is what they call DAPI, a distributive API. So that would be an API, an automatic programming interface, where you can basically pull information about the network. And there was a lot of great care done to actually, so when you're with your simple node, your phone, you can actually verify that the DAPI provided the correct information in a similar way to the Merkle proofs provide that this is a valid transaction. It was included in this block. The inputs for this block were included in this other block. So you can do that. So in a similar way, the DAPI is intended to be more or less a difficult to hack or an unhackable programming interface, or whatever, automated interface. Yeah. So where you can actually call, say, I want this information. Where's Joel's picture? You get Joel's picture. You can check the hash of it, check this hash that's in the platform chain, and then the hacker has not been able to spoof your wallet and give you the wrong picture for Joel.
Yeah. So basically, as far as people are trying to optimize for things, right now, it's pretty much impossible for the average person to participate effectively in the mining level of things, the ultimate final level. You kind of have people running data centers and stuff doing that in most chains. Now, and
if everybody was doing it, some people would outcompete the others. So
of course.
It's not even a goal worth trying.
Yeah.
I think, and then you think about BTC, which is optimized to run on a Raspberry Pi, which I think the way the debate went, that's not an overstatement to say that. Well, of course, a network that's running on Raspberry Pis can't offer the same level of service to a network that's running on a regular computer, right? My computer at home, its internet connection cannot provide a web service to you, but I can get a VPS for $20 a month, and I can provide as much web service to you as I want, more or less. As I mean, if I if I had get slammed like Twitter, I would need to pay a bit more. But
Yeah, so basically that's the trade-off we're hitting is there's a lot of disingenuous stuff, as you mentioned, about what the trade-offs mean. As in, people say if you don't run your own node, you can't validate transactions, whatever. We got rid of that misconception or possibly disingenuous thing to say. So it's just, if someone would rather run their own node, it would be much harder to do it on I would say, like an industrial strength blockchain like Dash, unless you're a master node or whatever, or unless you beef your stuff up, and that's fine. It just, if you want to be a hobbyist with your little Raspberry Pi in the corner, you can run a Bitcoin node, but that has the trade-offs of all the on-chain scaling stuff. It's going to be hard to scale.
You mentioned you have your own node on the laptop, so great.
Yeah.
Now, I believe with Dash's roadmap and with the usage I hope it gets and expects it to get, eventually you won't be able to run a node on your laptop. But if you try to run a BTC node on your laptop right now, I think eventually, unless you got a 8 terabyte drive on there, you're probably going to run out of space.
Yeah.
So, the fact that BTC was trying to give you the ability to run a node on your own computer, but then you still have to buy, you have to buy this 8 terabyte drive to do that. It's just, it's like they actually kind of failed trying to do what they were trying to do. They failed, optimizing their network to run on software that can't provide the same level of service that run on hardware. They failed. They failed. They don't. Their own spec doesn't work, right? Yes, it runs on a Raspberry Pi, but you would need to get at least a 2 terabyte drive, probably 4 or 8. To do that. So it's like, what you might as well just let somebody else hold that 8 terabytes for you. Maybe it's 3 terabytes now or something. But you better let somebody else hold that for you and just take a Merkle proof. Yeah. And then you have all the headers. That grows at a linear rate, the same amount per year, and it's the same amount that when Bitcoin started at 2009. So it actually uses less of your computer resources as computers get better and better as a relative use of your resources. It doesn't change the amount of resources it uses doesn't change over time. Merkle proofs get a little bit harder, but So, but it's that's logarithmic. But anyway,
well, that's ultimately what people do is. Obviously, there's some things that are by objective criteria better than others, as far as like throughput, as far as things like that. But ultimately, what people are doing is they're optimizing for things that they value, and what seems like the Dash community does not value, or the Dash network does not value, is for everyone to be able to theoretically run their own node, kind of a thing.
Right.
But what the Bitcoin community does value is that same thing in theory. Or even though you pointed out that because of the hard drive requirements, it practically is still kind of not that different, because you still can't do that. But they want to be able to do that on that, and so they're optimizing for that. Every metric is kind of arbitrary if you think about it. But to be able to say I can run on my computer minus the hard drive space, even though there's the caveat, I can run on my computer minus the hard drive. Even though there's the caveat, they're optimizing for that thing that is valuable to just be able to say it, that I can run it. So to my personal mind, again, I might be biased. I don't think that's a smart thing necessarily, but that is the trade-off at scaling that we kind of went full circle of, like on-chain scaling. It's like, oh yeah, we can do all these wonderful things. What's the trade-off? Well, that's the trade-off. It might not be a big trade-off, but it is one.
If you're not running a node, you could get spoofed about the total amount available, but it's basically conspiracy level. There would literally have to be conspiracies. People would have to conspire to provide these SPV nodes with spoofed information, and if you have, and it works, and if they don't have over 51% of the hash power, they're not going to be able to spoof it. And if they did have over 51% of the hash power, why aren't they just on the network and earning rewards? So it's just kind of weird. That they say that. Now, I mean, there might be with SPV, there's privacy concerns. the privacy that on SPV wallets has generally been provided by a Bloom filter. Um, I believe that is having some scaling hiccups. But if you gave, so I mean, when I say just in general, I'm like, maybe in order to be 100% private, you need to run your own node. But even if you're using SPV, you can use a VPN. You can use, if you really wanted privacy, you can get privacy a lot cheaper.
Yeah.
Let's see. There's some other things. Yeah. So.
Yeah. Everything does indeed have trade-offs, and just like having, I'm sure you could scale a on-chain network to the whatever Dash is trying to do, possibly easier or cheaper if you didn't include the instant send and chain locks requirements necessarily. But, or I mean, at least from the Sybil tap thing, there might be some trade-off with that, but it's a much more secure and usable network.
I think it's really marginal. It's not like you need to half the number of transactions because you've got to devote the resources to instant send. It's like marginal to negligible.
Yeah. Well, see, that's another case of we're talking about optimizations and things like that. It's
Right.
not
It's
only
why not?
it's not only trade-offs. Sometimes the trade-offs are virtually non-existent for just doing things smarter,
Right. Yeah. Yeah. I mean, like, I wrote up the thing about the extend and compact blocks opens up the poison block attack, but so that's what the trade-offs are.
Yeah. Well, and also if you think about it, instant send and chain locks wouldn't really work without a collateralized node, because then you could Sybil attack the network and then make a...
Oh, yeah.
And so that is a trade-off that then you have to have a big pot of Dash in order to run a master node. But that's a, again, acceptable trade, but it is a trade-off.
And that's something that I don't think I see in social media that people don't quite understand. It's the having the Dash up front to run a master node is not really intended to be like a staking thing or anything like that. It's just to prevent. It's to do two things, actually. It's to prevent a Sybil attack, which is that one person pretends like there are 100 people, right?
Yeah.
Which you can do on the Mastodon network, but you just need to have 100 times the collateral. So eventually you'll run out of collateral. So that way you limit the amount of times people can say, like basically one person can overtake the network by just saying there are 100 million people. So you mitigate the Sybil attack. That's the first thing that this does. Another thing that having the collateral does is it helps the economic incentives align. So the people that are voting on the network, the people that are doing that have an interest in the price of Dash doing well, have an interest in Dash doing well in general, have an interest in being able to spend their Dash or being able to use their Dash in new ways or, whatever, right? So it does those two things. It helps align the economic incentives, and it mitigates Sybil attack. You can't have a Sybil attack because of it. So it's not intended to be, you're earning interest. It does work out that way, but that wasn't kind of the design specification. It's just a result of the design specification.
Well, this has been a fantastic chat, and I'm sure a lot of people will be very, very interested to learn more. So where can people learn more about your work in this domain?
Well, there's ASU. If you go to blockchain.asu.edu, you'll see some of our research there. But the thing is, the blockchain lab has actually produced so much research. So they've been they've not just worked on Dash, but they've been working on some of the private or the permission blockchains, specifically with Hyperledger. So there's lots of stuff you can learn there, but there's the two papers that we published about Dash scaling. I'm a co-author out of UMass with the velocity, the graphene protocol. We didn't even talk about that one, but that has some advantages. So that's where I would look it up. I would look at the papers because that's where I go. I don't trust it until I read the papers, and sometimes people ask me questions like, "Let me tell you in 3 months." But
yeah, of course.
But that's where you might want to learn more. The old discussion is kind of hard to cite that. There's the Nakamoto Institute, but
there's all kinds of stuff.
Yeah.
Yeah, well, it's It's very interesting. Well, thanks for taking the time to go chat with me today, and hope you have a good one.
All right. Thank you.